Okay, so can you hear me? Yes, loud and clear. Perfect. So now we need to dial down the expectations here. So thank you, Håkan, for that presentation. I have much fewer slides and much less extreme projects. Um, I'll be talking a bit about one of our research projects, and that's regarding environmental calculations. Just by show of hands, is there anyone involved in life cycle assessment or any type of environmental calculations here today? Okay, great. So is there is there anyone feeling that this is an important topic for us? Yeah, a couple of hands. Great. Okay. So this research project is done within something called Smart Built Environment, and that's where I will start talking a bit about today, just to mention that and why we're doing this. And Smart Built Environment is a Swedish state project, basically innovation program for the construction industry, and it started 2016 and it's ongoing for up to 12 years. So it's a pretty big initiative to make changes in the construction sector and focusing mostly on new opportunities with digitalization. And the purpose is basically making construction cheaper, faster, and more sustainable. And they do it through 8 main areas. One of these main areas is life cycle assessment. And that's where this project is part of it. There's a lot of small projects like this one in this research program. And the goals are set pretty high for this Smart Built environment. They want to have a reduction of environmental impact by 40%, 33% reduction for time, and 33% reduction in costs. So they have pretty high goals, and they align also with the overall industry basically. So they're doing a great job. We're part in one small project. So life cycle assessment, usually we shorten it by calling it LCA. You hear me say LCA a lot here, that's what I mean, life cycle assessment. And here I have a small soda can, and that's basically the classic example of LCA. I showed this also last year or 2 years ago. And how do we do then life cycle assessment here? Yes, okay, so we need to find out what kind of inputs do we have and what kind of outputs do we get. Okay, that's fairly easy, right, for an aluminium can. We basically need some aluminium, we need to transport it to our factory, we need to have some energy to melt it. And on the outside, on the output, we get the actual can and we get some wastes, right? So that's fairly easy. But when we take one step back and want to see where exactly does this aluminium come from? Where is the energy coming from? And how is the transportation done? Then the picture gets drastically more complicated. And if we switch to something that we're more comfortable with in this room here, concrete elements, it will get even more complicated since precast elements can contain a variety of things, not only one material. So, how do we do this? In this small research project that we're doing now, we've identified some common things that we all basically use when designing these elements. Sorry, I just do like this. I remember this from last year. I struggled a bit there. Okay, so we have 3 main areas, and the first one is actually the concrete composition, and by that I mean concrete recipe. So what kind of cement are we using? Gravel, water, is there any admixtures used in this concrete recipe? We need to find that out. Also, there is more than just concrete, of course, it's other materials. So we have reinforcement, we have also custom materials, and we have insulation. These are the 3 main areas that we have looked at. And even if it's not by volume, in a whole house, for example, in Håkan's presentations, it will be mostly concrete, right? It will be also reinforcement, custom materials, insulation, such, but they will be much less volume-wise than the concrete. But adding up, in a whole building, we will see some effects of these materials as well. Usually you talk about CO2, right? The carbon emission, but usually you have, that's the one that you generally talk about, but there's actually 16 parameters in what we call environmental product declarations, EPDs. So CO2 is only one of them. So for the other 15, these might have effect. And lastly, we also look at the factory consumption. So with that, we mean basically heating, energy usage for that factory, transportation of goods to the factory. All of these things are the other materials. What they are is one thing, right? Which type of steel do we use? But where do they come from and how far is it to our factory? That's another issue. And also the waste generated in the factory. So each factory produces, you don't use 100% of the reinforcement. You don't use 100% of the insulation. It might also be non-recyclable waste, for example. Okay, great. So with all these three main areas here, we can actually move on to do something, do an LCA calculation. And then what we've done is we've connected impact to a tool called one-click LCA, and it does exactly that, right? So we can feed it from Project Manager with these materials, and it does the calculation. And it's fast. It's a fast calculation of LCA. And it's also fully digital. So you can prepare, send, receive, do the calculation all digitally. You don't need to jump out of another tool. You don't need to prepare a lot of lists or map stuff. You can do that all right in PM. Project Manager, sorry, that was. So Bionova is the company doing this. So they have a lot of services. They try to help organizations meet their sustainability goals, basically. So in our turn, we want to help you meet your sustainability goals. And it's compliant with the most major certifications. So BREEAM and LEED. Has anyone heard about these? Raise your hands. Yeah, okay. So they have basically all of the certifications today, also local ones, national ones. And from my point of view, I think that one of the big things here is that this tool is based on structured data. So it's by definition then searchable in categories, and it's filterable, and it's pretty easy to find what you're looking for. The picture I showed you earlier of this tree here, then you need to kind of jump into another tool. You need to search for all of the materials. Is this really what I'm looking for? And so on and so on. So we will take a quick look at the module as well here, just to show you. And this is the project we have used. It's from Orbital. It's roughly 1,500 elements. We used it also in the previous research project, but then we had to do a considerable amount of manual work to get the calculation running. So now we've made it all automatically. So here you can see the actual module to your right here. And first we have the whole building embodied carbon. So basically by clicking this button, it will take all of the elements, all of the materials, all of the factory consumption, divided for at the moment tons per year for a factory, and calculate how much consumption to each element and stuff like that, and you will get the total CO2 value for your whole building within seconds. So it's pretty dramatic. It does a lot in that time. Also, you can point and click. You can select floor. You can select an element type, an elevation, whatever you select here, and calculate that separately. And here we have the settings, and that's basically where you can define all of these materials I talked about before. I will not show you that today because it's too much details. We will be losing ourselves in that. But there you can define all of this, your exact concrete composition, how much is cement, how much is water, stuff like that. What is your insulation? Who provides me the steel, etc. How far is the transported, all of these things. And finally, for those who want even more detail, then you can go straight to the one-click LCA web service web page, and there you'll get all of the EPD parameters, all 16 of them, divided by different EPD steps, and you can do further analysis and do much more. And we also added a coloring option, so if you want to see deviations of your element types or do some analysis, you'll also see it in colors. This is per CO2 per square meter. Yeah, so from what I think here is that to make environmental calculations work within the construction industry, I think it needs to be non-invasive. It cannot be a tool that you need to export out to, open up and do some other calculations, be an expert in LCA and stuff like that. I think it should be readily available to basically the ones doing the designing of the elements and for the factories, and being able to see all of these information while you're developing your project. I think that's one of the keys to do sustainable changes. Yeah, I think that's it for me. I had also some time for questions if there are any.
So what do you think? How many raised their hands about this is the future?
A couple of, I think more knew about the BREEAM and LEED than raised their hands. So I don't know. I think this is you can answer this more than I can, but we have started at least, and we have something that's ongoing. And please send me an email if you have any suggestions or ideas. We can talk about that.
Yeah. Okay. Good.